This is
when we use complex form of pressure, so how
You can speak Korean, then I can translate to Indra. Yeah, you can do that. For instance, you can write Px cosine. You can start with it. You will get exactly the same result, but you have to work with the cosine, sine, blah blah blah. If you prefer to follow that notation, then you can go. But what I'm saying is because we decide to use a complex notation. We decide to use a complex notation, arguing that it's very convenient. But in fact, it's not convenient when we handle impedance or intensity, right? Then maybe I can say, let's forget about using complex notation. Right? But in fact, the active intensity or average intensity, mean intensity, is 1/2, you will find out, real part of, this is simple. I didn't derive that yet, but in fact, as a result, active intensity or mean intensity is just 1/2 of real part of P, that is complex amplitude of pressure multiplied by complex conjugate of the complex amplitude of velocity. Therefore, we decide to use it. Okay? In the middle of the derivation is headache, but result is simple. Okay. Sine.
So if we use sine, then we change the p,
right?
The pressure.
Right.
So it's different pressure. We're
We-
using different thermal pressure in that time.
I will summarize my answer based according to your question. Okay, if I say P is P magnitude multiplied by cosine omega t plus phi, the phi is function of x, okay, then we have to calculate velocity based on Euler equation, okay? And because P is a function of x, phi is a function of s, we have the term that is in phase with the cosine, cosine, same term as the cosine, and also we have term that is related with the sine. And then we calculate the intensity. First, finding out the velocity component that is in phase with velocity, that means the term that has a cosine, that is active intensity. And then you can also find the reactive intensity, that is the velocity that is not in phase with the pressure, that is a term that has a sign. And you will get the same result. Okay, his question, Seung-Hwan's question is, why we are so disturbed by this kind of lousy derivation? And my answer is, in fact, later on, we found that average is just 1/2 of the real multiplied by 1/2 of the imaginary part of the multiplied by the time. if you invent some other way to do this, then I'm guarantee I will graduate. You will get a PhD immediately. No problem. So if you got the result during this weekend, then come to me. Who is your supervisor? And I'll persuade him to give you a PhD immediately. This is just a matter of convenience. But we found that active intensity has this meaning and reactive intensity has this meaning. Okay? So let me summarize today's lecture. First, we learned what? Learn that, okay? Impedance of a simple monopole has two terms. One is the real part, and the other one and the KR really dominates the behavior of a sound propagating from the origin, and that is look like and this one look like okay, and what the impedance look like for plane wave. It look like this. This is rho 0C impedance for P is P right? So I argue that over here it behaves like this, so this is far field. So over here. That is the solution. And in the appendix you can see that when we have two monopole together, then the impedance does not look like that, or a function of KR again, but that is related to the KR to the fourth and behaving rather differently. Okay, when we have two that we call dipole, when we have a two dipole with different phase, we call it quadrupole. Okay, the impedance of quadrupole is also different. The dipole is dominated by KR to the fourth. That means the dipole, it reaches far field more rapidly than monopole, right? Because it depends on KR to the fourth.